We have always been drawn to the unknown, to connecting the unconnected, to pass along stories and myths. Distant pulses of light delighted us, stirred our curiosity, and helped us navigate our journeys. History is reshaped every once in a great while by a single discovery that changes the world we live in. Today, we have a technology that has revolutionized the way the world communicates. That technology, the union of glass and light, is optical fiber. In 1970, Corning ignited the communications revolution by inventing the first high-purity, low-loss optical fiber for telecommunications networks around the world. Corning's innovations in the field of fiber optics have helped make possible high-speed communication technology that links neighborhoods, connects cities, and bridges continents. It's all due to a strand of glass thinner than a human hair. Three Corning physicists, Donald Keck, Robert Maurer, and Peter Schultz, believing glass could fundamentally change communication, developed a unique manufacturing process for an ultra-pure glass fiber that transmits light signals with low attenuation or signal loss. They received the National Medal of Technology from the President of the United States for their life-changing innovation.
The optical fiber is a remarkable structure, and it's fairly complex. The key was to develop a glass fiber that was actually made of two kinds of glass. And it was understanding and getting the right characteristics of the two kinds of glass that was one breakthrough. But figuring out how to manufacture it represented another breakthrough altogether.
An optical fiber is comprised of three basic parts. The core is the inner glass of the fiber through which light signals are transmitted. The cladding is the glass that surrounds the core and keeps light from transmitting out. Acrylate coating is then applied over the cladding to protect the glass from physical damage.
In the whole race to communicate with light, one of the most important things was the precision manufacture of the optical fiber.
Unlike many fiber manufacturers, Corning makes all the glass materials for its fiber, ensuring strength and purity for performance and longevity. It begins with Corning's outside vapor deposition process. In the laydown step of the OVD process, ultra-pure raw materials are precisely deposited in their purest form, vapor, on a bait rod. Quality control systems monitor the process so that each layer is evenly deposited on a target rod. This soot-covered rod is called a preform. This exacting process ensures optimum performance characteristics, including dispersion, attenuation, and fiber geometry. The soot preform is then placed into a consolidation furnace and transformed from a porous glass compound into a solid transparent glass so pure that its contaminant levels are measured in parts per billion. The size of the preform determines the length of the fiber that can be drawn from it. Corning's enhanced technology has led to larger preforms, ensuring improved fiber quality and consistency. In the draw process, the preform is lowered into a furnace and the tip is heated, causing a gob of hot glass to descend. Once the gob is removed, the fiber is threaded through a device that controls the speed of the draw. Corning technicians use precise computer controls to monitor the fiber parameters hundreds of times per second. Our automated system provides closed-loop feedback and makes real-time adjustments to ensure the fiber is kept within specifications. A protective dual-layer acrylate coating added to the fiber provides protection for handling, cabling, and installation. The coated fiber is tested to ensure the tightest geometric specifications are met, and then wound onto spools. Every centimeter of fiber is proof tested for strength at a minimum of 100,000 pounds per square inch to ensure its required capacity. Optical and physical parameters are measured and the fiber's performance against specifications is verified.
In order to ensure optimum system performance, Corning has always been an industry leader in achieving the highest precision in geometrical specifications.
Corning fiber reels are packed in protective plastic spool covers, and are bar-coded to track mechanical and optical properties. Packed in recyclable shipping containers and shipped to customers around the world.
We designed optical fibers to withstand conditions all around the world, and we designed different kinds of optical fiber for different applications.
There are two types of optical fiber, multimode and single mode. The core of a multimode fiber is nearly half the size of the optical fiber itself, 50 or 62.5 microns. A micron is 1/1,000,000th of a meter. In multimode fiber, many modes of light travel down the core simultaneously. This allows for the use of inexpensive light sources such as LEDs, light-emitting diodes, and high-performance vertical cavity surface-emitting lasers, or VCSELs. Multimode fiber is typically deployed in local area networks, storage area networks, and data centers requiring distances of up to 2 kilometers. By contrast, the core of a single mode fiber is much smaller, only 8 to 10 microns in diameter. This smaller size allows only one mode through at a time at a particular wavelength. Corning also develops high-performance single-mode optical fibers known as non-zero dispersion shifted fibers, customized for specific network applications. Corning's full line of optical fiber products are optimized for 850 nanometer, 1310 nanometer, and 1550 nanometer primary transmission windows, as well as emerging wavelength windows, making our optical fibers best suited for many applications.
It's absolutely amazing the challenges we're overcoming today. Challenges we didn't imagine 30 years ago.
Corning's optical fiber forms the foundation of optical networks worldwide. High-speed, high-capacity submarine applications for short-haul coastline and long-haul transoceanic networks. High-capacity, long-haul terrestrial fibers designed to connect cities. High bitrate regional and metropolitan ring applications. Local area and local access fibers designed to bring fiber closer to office buildings and campus settings and bring bandwidth to desktops cost-effectively. Commitment to quality is the cornerstone of Corning's business life. We understand, anticipate, and exceed our customers' expectations. This commitment was recognized when Corning Optical Fiber was named a winner of the Malcolm Baldrige National Quality Award. Corning is the only fiber manufacturer to have received this highly respected award for excellence in business quality, and we continue to operate and measure ourselves by its criteria. As a world leader in telecommunications R&D, we focus our efforts on the development of application-specific high-performance fibers. Our research and development has led to hundreds of fiber patents and includes a laboratory dedicated to improving fiber strength. Corning conducts system testing and modeling, in which scientists and technicians test the fiber, custom components, and modules we design to determine how they will perform in actual fiber optic networks. Corning's vision is to become the catalyst of innovation, the scientist discovering new solutions, the engineer creating new practical technologies, to continually seek opportunities that make a difference, empower people, enable the enablers, and change the world.
We've come a long, long way in the optical fiber communication revolution. But in my view, we're just getting started. Wait until you see what Corning comes up with next. I know our future will be full of light.
We are about brilliant ideas stemming from intelligent curiosity, sudden inspiration, imagination, and clarity. Corning is driven by possibilities yet to be discovered.